Are you ready to embark on a journey through time? Today we're going to uncover the hidden history of our planet, Earth. We'll explore the incredible impact asteroids have had on shaping the Earth and its inhabitants over millions of years. And you won't want to miss this because it all started with one giant space rock. Let's get to it. Imagine our solar system as a bustling city. The sun is the big business district where most of the action happens. The inner planets like Mercury, Venus, Earth, and Mars are the residential areas. They're relatively small and cozy compared to the gas giants like Jupiter, Neptune, Uranus, and Saturn. These big guys are like the suburbs, far from the center and mostly made of gas. Then there are the outer planets, like Pluto, which are even farther away and even more icy. It's like the frozen wastelands of the solar system. In this cosmic neighborhood, Earth holds a special place as the only known planet to support life. But did you know that a long time ago, it was a very different world? One major difference was the atmosphere. Back then, Earth's atmosphere was much thicker than it is today. This meant that if you were an early Earth resident, you would have been living under a thick blanket of gas. What exactly was this gas made of? Mostly carbon dioxide, nitrogen, and water vapor. And don't forget about the extra dose of greenhouse gases. So if you were around during this time, say 4 billion years ago, you wouldn't have needed a jacket. The planet was nice and warm. In fact, it was so toasty that it was like a sauna. No need for sunscreen either. There wasn't a hole in the ozone layer back then. Instead, ultraviolet radiation from the sun would have been everywhere. Life, as we know it, could not have existed under these conditions. The reason for this dramatic change was none other than water. Yes, the same stuff that makes up 70% of your body and causes those water balloon fights in summer. Water played a crucial role in transforming Earth into a habitable planet. You see, Earth formed just like any other planet in the solar system, from a giant cloud of dust and gas that collapsed under its own gravity. As it came together, things got hot, really hot, like the interior of a star hot. All the materials Earth was made of were vaporized, leaving behind only the lightest elements. When Earth continued growing, more materials joined the party, but they couldn't melt the already solidified core. Instead, they piled up on top. Over time, Earth ended up with layers like an onion, the core, mantle, and crust. Now here's where water makes its grand entrance. Around 4.6 billion years ago, Earth was still pretty toasty, thanks to the leftover heat from its formation. But then some 300 million years later, things took a cool turn when water vapor in the atmosphere started raining down. And let me tell you, it rained for a whopping 10,000 years. Imagine standing under a drizzle that lasts for 10,000 years. That's a lot of rain. Why did this happen? Well, Earth was still pretty close to the sun. But around that time, the solar wind started picking up. The solar wind, if you haven't heard, is a stream of charged particles constantly flowing from the sun. Now, these particles acted like bullies, pushing away the lighter gases like hydrogen and helium from Earth's atmosphere. Without this constant harassment from the solar wind, the Earth could have easily lost its protective shield. But wait, there's more. This cosmic downpour didn't just bring water to Earth. It also delivered carbon dioxide, nitrogen, and ozone. This transformed Earth's atmosphere into a more hospitable environment. You see, this intense rainfall created deep ocean trenches. These were massive low points on Earth's surface. Imagine being at the bottom of the Mariana Trench, the deepest part of Earth's oceans today. If you were standing in that trench, you'd be almost 11 kilometers below sea level. That's like being inside a big canyon. The water level was so high because Earth was still pretty warm and much smaller than it is now. The land wasn't spread out like it is today. It was squished together. Over time, Earth began to cool. The water started seeping into the cracks between the solid rock, forming deep pools beneath the surface. As it cooled, more water turned into ice and filled up those cracks completely. Before you knew it, Earth had its first underground ice layers. And guess what? They're still there today. We call them aquifers, and we tap into them to get the water we need. Here's another fun fact. If you dug a hole through the Earth and fell to the other side, you'd end up in Antarctica. Yep, you'd be surrounded by ice and snow. And yet, despite all this ice, Earth's average temperature was still higher than it is today. Why? Because carbon dioxide acts like a blanket for the planet, trapping heat and keeping things warm. Some scientists believe that these conditions lasted for quite a while, maybe even 1 billion years. But eventually, the amount of carbon dioxide started dropping. The planet began cooling, and around 4 billion years ago, Earth hit the freezing mark. But hold on a second. Wasn't Earth supposed to be covered in water? Where were the oceans? Well, here's the thing. Even though Earth was indeed bombarded with water during its early years, it wasn't entirely covered. You see, when the temperature dropped, most of the surface froze. Only a few kilometers near the center of Earth remained liquid. So if you wanted to take a dip, you'd have to travel deep into the planet. But it wasn't just water that froze. The carbon dioxide in the atmosphere turned into dry ice and landed on the surface. Pretty soon, Earth looked like an enormous snowball. We now call it the Snowball Earth event. So, how did life begin on this frozen wasteland? Scientists think that some microorganisms might have actually preferred the cold. They used chemicals from underwater vents to make their bodies run instead of relying on sunlight. As Earth thawed again, plants and animals as we know them today took over. But this period of intense freezing wasn't a one-off event. It happened at least once before, maybe even twice. And each time it reset life on Earth. Throughout Earth's history, the climate hasn't always been as stable as we'd like. There were times when it was way warmer and even way colder than today. But that's not all. Around 250 million years ago, Earth experienced something called the Great Dying. This was a mass extinction event that wiped out a staggering 96% of marine species and 70% of terrestrial vertebrates. What's even crazier is that it happened in a blink of an eye, geologically speaking, within just 50,000 years. But you might be wondering, what does this have to do with asteroids? Well, asteroids are like cosmic time capsules. By studying them, scientists can unlock secrets about the past, including the Great Dying. You see, asteroids often break apart before crashing into Earth. This means that they leave behind fragments that can be found in different places. Recently, researchers discovered one such fragment in Brazil. Its age dates back to the end of the Permian period, right around the time of the Great Dying. But this particular asteroid has a unique twist. It's a carbonaceous chondrite, which means it's rich in carbon compounds. Scientists analyzed this asteroid and made a shocking discovery. It brought along organic matter from beyond our solar system. This interstellar cargo included amino acids, the building blocks of life, and other crucial molecules. One theory suggests that these space deliveries triggered the evolution of life on Earth. Others believe that asteroids like this one might have played a role in ending the Great Dying, helping life bounce back. But some scientists aren't so sure. They argue that life might have taken a different path if it hadn't been for the Great Dying. Maybe the extinction of 96% of marine species was a necessary reset, paving the way for new life forms to flourish. It's like when you clear out old files on your computer to make room for new programs. In a strange way, the Great Dying could have been Earth's chance to start fresh. And as for the delivery of organic matter from beyond our solar system, well, that remains a mystery waiting to be solved. While the exact cause of the Great Dying might still be up for debate, one thing is clear: Earth has faced many challenges throughout its history. But life has found a way to not only survive but thrive. From the earliest microorganisms to the complex ecosystems of today, Earth's inhabitants have adapted and evolved in the face of changing environments. So the next time you look up into the night sky, remember that the stars you see are not just distant lights, they're witnesses to Earth's incredible journey through time. Each of them has its story to tell, just like our planet. And who knows, maybe someday we'll find answers to questions that have been bugging us for centuries. After all, the universe never ceases to amaze. That's all for now. But if you're hungry for more knowledge, don't forget to subscribe. And hey, Why not share this adventure through time with someone who loves space as much as you do? Until next time, keep looking up.